This is standards F1-5 review. You can go through and get the answers first. On F1, no, this is not a function. The input 12 has two outputs, 63 and 67. Number 5A, it is a function. Number 8, no, it's not a function. We can look at the graph and see that it fails the vertical line test. Also, the input 3 has two outputs. Number 9, yes, it is a function. It passes the vertical line test. All the x's are different. On F3, number 1 is nonlinear. It is not a straight line. Number 4, the second, which I'm going to just label it, second, fifth, and last choices, we'll call them B, E, and F, are all linear. Number 7 is linear because it's a straight line. F4, number 4 is choice B. Number 6, G is equal to 1.6t. And yes, it's a linear function because it fits y equal mx plus b. Number 7, y equal 15x, and she earns $120 for 8 hours. Number 13, y equal 15x plus 30, and it's $390 to rent a jet ski for 24 hours. F5, number 5 is B. Number 7, it increases for B and D, decreases for C and F, and constant for A and E. Number 8 is the first and last choices, and we'll call them A and E. F2, number 4, function A is 0.75, B is 0.5, so the function A has a greater rate of change. 7, yes, she's correct. Both functions have B equal to 2. The y-intercept is 2. And 8, no, he's not correct. These do not have the same slope. One is 6, the other one's 1/6, so they're different. We're going to work through the problems that you might have missed now, and some of these I explained a little as we went, so there's not any need to go back to. But let's go back to number 5. Number 5, we can look at this table, and we can see all the x's are different, so this is a function. We talked about number 8, we just plotted the points. Number 9 we talked about. Number 1. Number 4 on F3 might give you some questions. On the first choice, if we're just trying to determine if it's linear, we're looking at a table. Remember that we can just go through and see if the slopes are the same or different. So we can go through and test using the change of y over change of x. So I'll test a couple of these. I'm going to take my first two and say, okay, y goes down 150 when x goes up 5. So negative 150 over 5 is negative 30. And then test another one. I'll take these two, the third and fourth ordered pairs. Y goes down 50 when x goes up 15. So we have m equal negative 50 over 15. That reduces, but we still end up with negative 10 over 3. That is not negative 30. These are not equal, so this one's not linear. The second choice is linear because it fits y equal mx plus b. The next choice is not linear because it's not a line. The next choice, if we were to go through and find the slopes, change of y over change of x, if I take these first two, I get that it increases 0.1 over 1. Whereas if I take the next ones, it increases 0.5 over 1. So these are different. It doesn't work. That's not linear. Choice E could be rearranged to give us y equal 2/3 x minus 8. So that is y equal mx plus b. So it's linear. And F is a straight line. F4 Number 4, Ivy grabs how much money she earns for hours of babysitting. She finds that the data tends to be linear and draws a line that passes through these points. About how much does she earn per hour? Well, we can find that. This is actually going to be a slope problem. We have different ways to do that. I might plug them into a table of values and say, okay, here's one ordered pair. Here's another ordered pair. And I would like to know the slope. So I'm going to say M is equal to the change of Y over the change of X. Well, Y increases 19.5, where X increases 3. When we divide that out, we get 6.5, which is choice B, $6.50. Number 6, Max puts a stopper in the bathtub and turns on the faucet at time t is 0. So just to start here, at 0, 0, he's starting to fill the water. It says 0 minutes with 0 gallons of water. After 5 minutes, there are 8 gallons of water. After 10 minutes, there are 16 gallons of water. So I could use this information to find M, the change of Y over the change of X. And I could say, okay, the change of Y from 8 to 16, it adds 8. And from 5 to 10, it adds 5, which is 1.6. It starts at 0, so we have this equation, Y equal 1.6x plus 0. And Y is talking about the number of gallons. X is talking about the time, and we don't have to write plus 0 there. So we found the equation, and yes, it's linear because it fits Y equal mx plus b. Number 7, write an equation to represent this function. So we'll just look at a graph and say, okay, it starts here where b is 0. And then we can pick any 2 points. I like this point and this point. I'm going to say, okay, the slope is the change of Y over the change of X. Or Y goes from 15 up to 30. That's increasing 15. And X goes from 1 to 2. So it's increasing 1. Be careful. Watch what units your coordinate plane is counting by. So M is 15. So we get Y equal mx plus b. So Y equal 15x plus 0, which is just 15x. And then to get how much she earns for 8 hours, we can't fit that on our coordinate plane, but we do know this. We know we can just plug in and say, well, x is the number of hours, because x is hours worked. There's 8. We multiply and get 120. Number 13, we're going to write a linear function. So we're going to start out there and think, okay, if x was 0, what would be y? It was counting up 2 every time on the x's, so we could go back 2 to get 0. The y's are counting up 30 every time on the y's, so we can go backward 30 to get 30. So b is 30. And then for the slope, change of y over change of x, we could say, okay, from 60 to 90, it increases 30. From 2 to 4, it increases 2. And I can do this between any 2 ordered pairs on my list. And I get that m is 15. So that's where we get our equation y equal 15x plus 30. Now to get the last part of it, if we plug in y equal 15 times 24 plus 30 and simplify that, we do get 390, and that's where $390 comes from. F5 is heavily looking at graphs. 5, we're just describing this. The boat travels at a constant speed, so it's just going straight across, and then it slows down, so then it's decreasing or dropping. Number 7, the graph of the function is increasing, in these places. B and D, it's going up to the right. It's decreasing at C and F, it's going down to the right. And it's constant or flat, staying the same at A and E. Number 8, describing our interval 1. Well, it's going up to the right, so it's increasing, which also means it's positive. The last standard, F2, starting with number 4. This standard is asking which has the greater rate of change. So it's going to require us to find slope, which is another name for rate of change. So I'm going to note that. This is talking about slope, M. So I can find slope in this function A. It's the change of y over change of x. And pick any two ordered pairs. 3 to 6 goes up 3, while 4 to 8 goes up 4. And if I want to change that to a decimal, that's 0.75. Looking at function B, it's in the form of y equal mx plus b, so m is 0.5. And so 0.75 is the greater value. Number 7. Emma says these have the same initial value. A quick reminder, initial value is another name for B, the y-intercept. So on number 7, it is 2, because that's where the line crosses the y-axis, it intercepts there. And now for function B, we're thinking of where x is 0. Well, if we are adding 2 every time to the x's, we could go back 2 to get x is 0. If we're adding 1 every time to the y's, we could go back 1 to get y is 2. So B is 2. And so these are both, she's correct, they're both the same. And by the way, one thing to note, this is where x is 0 when we're finding the y-intercept. Number 8, Nolan says they have the same slope. Well, if we look at function A, it does fit y equal mx plus b, where m is 6. And then if we look at function B, we could find the change of y over change of x. So I could say, okay, 9 to 10 is adding 1, 8 to 14 is adding 6, and that's a slope of 1 over 6. These are not the same numbers though. 6 over 1 is not equal to 1 over 6.